So welcome to today's class. We'll be going over decimals today. So let's start with an example. This is example 13, continuing what we left off. What's the ratio of 0.1666 to 0.8333? So how I would like to do it is think of making that fraction. Alright? So 0.16666 and on forever. It's just 1/6 if you were to make it into a fraction. And then 0.8333 is going to be 5/6. So then now the ratio is just 1/5 from there, right? So some repeating decimals it's okay to memorize. Like it makes life much easier. Like for example, 0.16666 and on forever. It's just 1/6. Just memorize it like that. Alright, let's move on to problem 5. On the number line below, which of the following is the best approximation of u minus v? Okay, so I want the absolute value, so we know it's going to be positive, right? So u is negative and v is positive. So u minus v is going to be negative, right? We can approximate u as to be -2 because it's extremely close to -2, as you can see. And v is like about 2.5. So then we get u minus v as -4.5. And taking an absolute value, we get e, 4.5, which is our best approximation. All right, let's move on to problem 6. Calculate 1.436 repeating, over that repeated, minus 0.312. So, does it have the same number of numbers in the cycle? As we talked about before, if we just take the LCM, if the cycles are different, or the least common multiple of the amount of numbers we write out, if the cycles are different, say this is 2 and 3, least common multiple is 6, so we write out the 6 numbers with the cycle repeating, right? For example, say it was 1.43. It should be, we write out 1.434343, and then we write 0.312312, right? In this case, the cycles are the same. They're both cycle every 3. So it becomes 1.436 minus 0.312. Notice, this just makes life easier. You see this is a 1, this goes on 1, 2, 4. And this put the repeat because after this is going to be a 4, 3, 6, and 3, 1, 2. And I'm just going to repeat all over and over and over again. You can do it for every single repetition. It's going to take you forever because this is literally forever. Right? This is going to be 1.124 or A. Right? You can do the same thing for problem 7. You do the same method as we did, but as we talked about before, try to make it in the cycle. Right? So in this case, 2.35 is repeating, but this isn't a 3-digit repeating cycle as the other one, which is 0.342 or 42. So we write out 6 in this case. But this one's but that's if you don't see this clearly, as I just did. It's 0.34242 repeating. So think about it. We write 2.3535 and see what we can do about that. Right? So when we're thinking about this, we want to find a way to make it like kind of it's a repeating, and we can't try to solve these questions and make their repeating less annoying, to be a matter of fact. So in this case, we just take 353 because it's gonna be 342, and we can just do it like this: 2.3 and 53 repeating, and this is gonna be 0.342 repeating. Now, why is that true? Because 3535 repeats the entire time. If we just take away that 3, And just add the 5, 3 repeating. We get 2.353 repeating plus 0.342 repeating. That's the exact same thing as 2.35 repeating, right? That just makes life much easier. So let's rewrite this. Instead of 2.35 repeating, kind of confusing, we write 2.353 repeating plus 0.342 repeating. I'm going to add that up. This gives us 2, 3, 6, 9, 5. Or 2.695. And remember, 95 is repeating. Only 95. So the answer is B. Let's go on to try on problem 8. This is a quite different problem. I'll just give you a hint that this is 1/7 right here. This is 1/7. And 3.55 repeating. You know that 0.111 repeating is just 1/9. So if it's 3.555, I'm pretty sure you guys know what's gonna happen next. Let's go to try on this and tell me answers in the chat. Alright, guys, let's get started with this question. I hope you guys had a thought process, or at least attempted on how to solve these questions. Right, so notice that 142,857. It's a cyclic number. It's just so you know, it just when you like multiply it by the first couple of numbers we learn, like 1, 2, 3, 4, 5, 6, 7, it actually cycles. It becomes 142,857 to like only using these 6 digits. It cycles basically, except for the last one, it just becomes 99999. If we multiply by 7, right? This is just 1/7, right? And then 3.555 is just 32/9. 3 and 5/9, or you could do 32/9, right? So you're multiplying 32/9 times 1/7, which just gives you 32 divided by 63, is E. So you just needed to find out what does 0.14285 which is what. That's the hard part. Alright. Now let's move on to problem 9. Express the product 0.63 times 3.6 as a common fraction. Basically the same thing. This is just 33/9 or 11/3. Alright? And this is just 63 divided by 99 or 7/11. Alright, just multiply just gives us 7/3. That's basically how simple it could be, right? Same thing with this one. Since it's 0.1 and this is 0.001, we just go 0.111, 0.001, which just becomes 0.112. Repeating, which is 112 divided by 999. Problem 11, basically 2/9 times 4/9. Basically, just using the methods we can do here, we did before, we can just solve these questions extremely fast. It just becomes 8 divided by 81. Just doing these problems is just a breeze, right? Now, problem 12. Express the difference between 0.5 and repeating and 1/3 as a common fraction. 1/9 is 0.111 repeating. Then 0.5 repeating is just 5 times 1/9, which is 5/9. 5/9 minus 1/3 or 3/9 is 2/9, or C. Example 14. How many positive integers less than 100 have reciprocals with terminating decimal representations? Terminating means stop in this case. So the answer is just going to be the multiples of 5 and 2. Why is that? Because basically, if it's not, it's going to terminate, has to be a multiple of 2 and 5 because we're in base 10 basically. For example, 2 times is 1/5 or 0.2, and 1/5, 1/2 is 0.5, and you can see the rest, basically. So then we just want to find the number of fives and twos, multiples of fives and twos only. That only made of 5 and 2. So basically, we just want to find the factors of 100. But that's not. Basically, 100 and some multiples of powers of 2 and powers of 5 combined together. This is just going to give us, just pretty, you guys can count by yourself, and this should give you a count of B, or 14. Basically counting the integers down powers of 2, 5, or both. Let's move on to example 15. Now let's give a try on this question and tell me answers through chat. Alright, let's get started with this question. Basically, the answer to this question is A. So now, how are we supposed to solve it? Notice that we can write this as we talked about like 2 classes ago, something like that. We talked about repeating decimals, that they're gonna be nines on the denominator normally, right? So for example, 6/99 is just gonna be 0.066666 because 2 9s mean there's 2 repeating digits and there's no zeros. There's no non-repeating digit. I'm just gonna give it a 0.0666. 0.060606 and on forever. Now if it's 3 divided by 11, the denominator should be 11. So we multiply by 9 to get 99. Therefore we multiply on top by 9 to get 27/99. Or the repeating decimal is just 0.2727. And so on. So the answer is A. Right? Let's move on to example 16. Let's you guys will try this question and tell me answers through chat. Okay, let's get started with this question. So basically, how we're supposed to do this is basically notice that 17 divided by 35, we just basically plug and chug, just basically divide, just do the division. And we just get 0.485714. That's basically the way to do it. There's no shortcut because 17 shares no common factors with 35. So what we're left with is just to divide it out. So the answer is then 43, I mean, uh, A. Because it's not rounded to the nearest hundredth, remember? Read the question carefully. It says tenth. So it's going to be 0.5. Right? Let's move on to example 17. What is the absolute value of the difference between 0.35 repeating and 0.49? Alright. So basically, we're just gonna subtract. Since there's the same number in each cycle, so there's 2 in each cycle, we can just straight up subtract. This is going to give us 0.14 repeating. So 14 over 99. If we see these types of questions with the same, just subtract.